class, we're now beginning chapter 5. We are going to start with Lewis symbols and the octet rule. So chemical bonding involves charges in the atom's outer or valence electrons. Remember that valence electrons are the electrons in the highest occupied energy level of an atom. Because of the sublevel filling sequence, the valence level involves only the s and p sublevels. Since 2 electrons can fit into an s sublevel, and 6 electrons can fit into the p level, in the p sublevel, up to 8 electrons can occupy the valence shell. So the 2 here, so it would be 1, 2, 3, 4, 5, 6, 7, 8. For our main group elements, we can quickly determine the number of valence electrons from the periodic table. The column or group, which is going downward, number for the main group is also the number of valence electrons. So for nitrogen, which is N, we see at 5A, has 5 electrons. Neon is in group 8 and has 8 electrons. So you can see down, this is 3, 4, 5, 6, 7, and 8. So in order to visualize chemical bonding, we use something helpful, and that is drawing Lewis structure symbols. So what it is it's the symbol, and then we use the valence electrons around it so we can visually see what we're dealing with here. Because what we're going to do is these elements will interact with each other. And by using Lewis dot structure, we can visually see what's occurring and where these electrons go. So these symbols represent the number of valence electron in an atom as the dots drawn around the atomic symbol. Look at the Lewis dot structures for elements in row 2. So what you see right there, starting at lithium and ending in neon, is row 2. So you see lithium has 1, beryllium has 2, boron has 3, carbon is 4, nitrogen is 5, oxygen is 6, fluorine is 7, and neon is 8, and everything below that matches that. So for the first 4 atoms, we draw the electrons individually. So if you notice, they're not paired together, they are separate up into carbon. At 5A, we have more than 4 now, so we begin to pair them off. So that's when you see that they're paired off until everything is completed to 8 electrons. Why do we do this? Because it's lower in energy. So this is an appropriate way that you represent electrons around an element, an atom, is you have to keep them separate because that's lowest in energy, and you only pair up when you have to. So the octet rule. In chapter 4, we introduced the octet rule, which states that an atom is stabilized by having its valence energy filled, which is up to 8. For elements in row 2 and below, 8 electrons are required to fill the valence level. And so the neon, the noble gases are the only ones that have 8 filled electrons. So it has a filled octet. Everything else does not in that row. So notice that in row 2, only the noble gas neon has 8 electrons and fulfills the octet rule. Noble gases are stable because they fill this rule. The other atoms can also fulfill this rule by gaining or losing electrons to form ions or by sharing electrons through bonds, which is what we're going to start learning. So which of these is the correct Lewis dot symbol for sulfur? So if we look at sulfur, sulfur is an S and it's in group 6A. So that means it should have 6 electrons around it. Now let's take a look. This is 3, this is 8, this is 2, 3, 4, 5, and this is 6. 2, 4, 5, 6. So it's going to be D, and it's not paired up until it has to. So the correct answer is D. This is from another of my slides, just to give you a visual of what I was talking about here. You can see everything down here is 6, everything here is 7, and so forth. So that should give you a better idea visually of what we're dealing with.